In this tutorial, I'm going to develop a microservices application with Eclipse. This is a very simple app that consists of 5 modules that are deployed as microservices. This is To-Do API, Users API, some front-end, and Authentication API. Each module has a Docker file and deployment YAMLs. So I've deployed it to Minikube, so you can see all of the active deployments, and let's check out the application itself. It's a to-do app. Let's create a new one. All right, so the app's functioning, but what if I want to develop this application using the same environment? I've constructed this huge YAML that consists of pods and services. So it's kind list, and I've got pod definitions for all of the microservices and respectful services for them. This is a single user Che, and this is a workspace that I've created using this recipe. You can see the definition of each machine. It references pre-built images. So Authentication API, Frontend, Redis database, To-Dos API, Users API. And I've got 2 pods that provide some tooling for my workspace. Installers reference exec agents and terminals. There are also servers, one for the language server and one for the front-end application. Almost all of the machines share /projects as volumes so that each machine has access to project files. And this is how workspace config looks like in the end. All right, so this is a running workspace with all of the machines that are up. Let's take a look at the first component. This is a service written in Golang. You can see that the language server is functioning there as a sidecar and provides some functionality like go to definition. Let's check out some Java file and do the same. All right. So this way we can provide language tooling as sidecars on top of your production definition. So this application is running in my Che workspace. It uses the same images as in production, so I can be sure that it's an identical environment. So let's see if app is okay. It looks like it's okay. Now let's do some changes here in to-do file. Add a new cool to-do. And what I'm doing now is I'm executing a command, which is basically a command that is executed in a pod where a particular microservice is running. So in this case, I will stop the server and restart it with my changes. Luckily, I've got project sources in all of the containers. All right, it takes like a few seconds to redeploy. Let's refresh and add a new cool to-do. So from now on, I can edit my source code and files and preview changes live. Of course, if the server has been launched in watch mode. Okay, let's play with a different microservice. This is a Golang server. Let's change the message if I've forgotten my password and provided the wrong one. Sorry. All right. I'm executing a command, stop the server, run go build, and run the server again. Okay, Let's check out the app, log out, and provide a bad password. Good. Okay, and yeah, I can do like that, and each time, yeah, don't forget to redeploy. Since this server doesn't support watch mode, you have to compile it into a binary and then restart. Okay, so next thing is we can do something with to-do API. Let's open the to-do controller and find some message here, create a new to-do. Okay, update me, please. Good, and execute a command. All right, the server has restarted, and let's provide a good password. Update me, please. Right, so I can keep on coding or providing changes in my source files, and yeah, just refresh the page, or the page may refresh itself. It depends on the technology you're using. All right, let's play with Spring Boot application, Spring Boot microservice. This is a user's API. The first thing I'll do is actually build the artifact. So this will be a jar. All right. It runs some tests here. Okay, once done, I can then launch this jar in a debug mode. And note that I perform Maven build in one container and run this jar in a production container that I'm using the same one in my Minikube. Okay, I've set a breakpoint, and let's connect a debugger. I will use a service name, users API, and the port here, and click on debug. So once again, I'm connecting from one pod to another pod. Now let's log in, and I'm expecting to be stuck here. Let's check out the debugger panel. All right, we've hit the breakpoint. So, well, nothing special here, just a typical debugger panel with step in to step over, evaluate expression, change expression, and whatnot. All right, let's disconnect the debugger. What I can do now is I will actually commit and push my changes back to the original repository. So let's recall what changes those were. Okay, and do a git push changes, and I will push it automatically to my GitHub remote. Now, my CI may, trigger a webhook. So the GitHub may issue a post request to my CI system. Well, for this demo, I'll just execute a simple script that will do a Docker pull, rebuild and tag images, put them to Docker registry, and then update my Minikube deployment with the new image tags. Once done, new tags are pushed to a Docker registry, GitHub in this case, and you can see the new tags are used in my Minikube deployments. So this way I can simulate staging, so to say, and actually test my changes in a production environment, even though the environment that I used in my Che workspace doesn't differ. I can then use updated images in my Che workspace and modify my machine recipes to reference the newer images.